Hello students, I am going to teach you now or give you the overview of the subject signals and systems. Brief introduction of the faculty who is teaching the topic. I am Sripathi Raja, faculty of biomedical engineering who has an experience of 20 years plus in the department of biomedical engineering at BVRT Narsapur. Introduction. So the title of the subject is signals and system. We would like to know first what is a signal and a system. Then we will like to move on to the contents of the course. First we will like to see the definition of the signal. Yes, it is clearly written that it is a single valued function of one or more variables that give you some information. Okay, nothing but some function which can be represented on x, y, or like just an image where we can see the examples. This is an analog signal. Analog signal is nothing but a continuous time signal. This is a digital signal where zeros and ones are represented in the form of a wave. These are the biological signals EEG. EEG is nothing but electroencephalogram, which is taken from the brain in order to diagnose some diseases with the patient or the person. This is ECG, electrocardiogram, nothing but the waveform which is generated because of the heart activity. This is EOG, electrooculogram. It is the waveform which is generated because of the activity of the eye. So these three are biological signals. Signals which are already available in the human body. Yes, this represents a image which is famous known as the Lena.tiff, which is used mostly in image processing. So this image is also a signal which is two-dimensional. A video which you see in YouTube is also a signal. So signal is something which is function of time and another variable. Mostly we will see in this subject with only single variable as the function. We won't be considering two variables as a function for our course. Then we'll come to know what is a system. A system is generally defined as an entity which acts on an input and produces some output. The smallest system which is available is this is the low pass filter with only two electronic components R and C. They are connected in such a way that it gives only the required output, nothing but remove the high frequencies and produce only the low frequencies. This R and C two components can form a low pass filter which is a system. Similarly, at a household you can observe the AC which you have. This is washing machine which you have at home. All these are examples of systems. So when we come to the definition of a system is an entity which acts on a input and produces the output, that is called as system. In order to study this particular subject, signals and systems, what are the prerequisites we should have so that we can easily understand this subject? The first one is differentiation, the knowledge of differentiation, the knowledge of complex numbers, the knowledge of integration. If we have these three, differentiation, complex numbers and integration, we can easily study the subject signals and systems. What is the unit 1? Unit 1 is nothing but it is about signal analysis. So first, as the subject indicates, signal systems, we'll see the definition, then go for classification of the systems, introduction and then classification. There are plenty of signals available. How do we classify them? There are plenty of systems available. How do we classify them? All those things we will see. Why do a biomedical engineer studies this particular subject, signals and systems, and this particular topic is, yes, as we said, plenty of signals are available in human body. Under which category does those biological signals come under? So that we can know by studying these general classification of signals. There are plenty of systems available in the human body. So under which category those systems come under can be known once we know the classification of systems. Then the third will be the analogy between vectors and signals. In our 10th class and below that, we have learned what is a vector, what is a scalar. Scalar is which have only magnitude, whereas the vector is have only both magnitude and direction. So we have already studied what is a scalar, what is a vector, and we also know what is dot product, what is cross product. So based on those basic terms which you already have, we will try to give analogy of those vectors to the signals so that it will be easy for us to understand those signals. Then something called as orthogonal signal space. With vectors, we will be learning orthogonal vector space. As vectors have an analogy with respect to signals, we also learn orthogonal signal space. Once we learn orthogonal signal space, the next one is approximation using orthogonal functions. So what is sine and cosine functions are orthogonal functions. So you can represent any signal by using those two signals. The next one is mean square error. We will be learning what is mean square error and how to derive the expression for those things over here. Then the complete set of orthogonal functions will also be learning after that. Then the orthogonality in complex functions we like to see. So this is the basic introductory unit where we'll be understanding what is signal here and how signals are approximated we will be learning. Then coming to the next unit, unit number 2 is Fourier series and Fourier transforms. So these two transforms we will be learning over here. So Fourier series has representation of Fourier series, continuous time periodic signals, then properties, then what are Dirichlet's conditions. These Dirichlet's conditions are nothing but the basic conditions which a periodic signal should have. Otherwise, if they don't satisfy these Dirichlet's conditions, we can't even apply the Fourier series transform to that. Then we'll see different types of Fourier series, nothing but trigonometric Fourier series, exponential Fourier series. This is one type, trigonometric Fourier series. This is second one, exponential Fourier series. The third one is complex Fourier series spectrum. Then we'll move on to the Fourier transforms. The difference between Fourier series and the Fourier transform will be the Fourier series are used for periodic signals, whereas the Fourier transforms are used mainly for aperiodic or non-periodic signals. So those classification we have already studied. Once we know the classification, then we have come to the transformations which can be applied on those signals. Why do we use a transformation? In one domain, we may not be successfully or clearly viewing that signal for an application. When we transform into particular domain, either frequency or something else, then the observation will be much clear for us to understand its application. So that is why we undergo signal transformations. Under that, Fourier series and Fourier transform are two different transforms which we study in Unit 2. Unit 3 deals with signal transmission through linear systems. So we have already studied system and its classifications. Here we are going to understand what is a linear time LTI system, linear time invariant system. Through that, how does a signal transmit? So how to transmit a signal without any loss or lossless, distortionless signal transmission. All those things can be understood by reading the third unit. Along with that, we will also be learning what is the impulse response and step response. Mean to say, the particular system is given with an input of impulse. What will be the output is nothing but the response. So, what will be the output of a system when the input is impulse, that is impulse response. The second one is step response. The system is LTI system, but the input now is step input. Then what is the output which LTI system develops is step response of LTI system, that we will be learning over here. Then the topic is filter characteristics of linear systems. So we already know what is linear system. Then these filters, what are the different filters a biomedical engineer uses, or an electrical engineer uses, or a electronic engineer uses. There are different types of filters which are available: low pass, high pass, band pass. So this is simply represented LP, high pass is represented with HP, band pass is BP, band reject or band stop. So band reject or band stop filters. So for filter, F is indicated. So these are the different filters, general filters which anybody uses. So we will be learning the filter characteristics of these kind of filters here. Then what is the signal bandwidth, what is the system bandwidth, we will come to know once we relate those filter characteristics. Then we will see how this low pass filter, high pass filter and band pass filter characteristics look like ideally. And when we develop them on a breadboard or on a PCB or using some simulation software, how does its characteristics look like? What is ideal? What is practical? Those can also be learned over here. Then we'll come to know the causality and Hale-Weiner criterion for physical realization of these filters. Then we'll come to know the concept of convolution in time domain and frequency domain. Convolution is possible both in time domain and frequency domain. That we'll be learning what is convolution and how it can be done in time domain and frequency domain. Then the convolution property of Fourier transforms will also be learned in unit number 3. The next unit, unit number 4, includes Laplace transforms and Z transforms. So we have already studied two different transforms in unit 2, which are Fourier series and Fourier transforms. In unit 4, we will be learning Laplace transforms and Z transforms. So when we learn, so first introduction should be there. Then what are how to write the inverse Laplace transform. Once we develop the Laplace transform, here we come to know a particular topic called as ROC, region of convergence. We'll let to know what is this region of convergence for Laplace transform as well as for Z transform too. Then properties of Laplace transform. Then how do we relate this Laplace transform with Fourier transform, Laplace transform and Fourier transform? What is the relationship between these two? So those things we'll also be learning. Then comes the Z transform. So we'll again learn the Z transform concepts, the definition of Z transform and the equations of Z transform. Similarly, as we learned there, here also we will be learning the region of convergence ROC in Z transform too. Then there are certain constraints which are there on region of convergence, nothing but ROC in Z transform. So those we will be learning based on the type of the signals which we are using. Then as we studied over there, we will also be learning the inverse Z transform. Then we will also learn the properties of Z transform. Why should we as a biomedical engineer should learn these many number of transforms? Yes, Laplace transform, its application is control systems. So this control systems is read by all types of engineering branches like electronics and communication engineering, electrical and electronic engineering, Even MBA people require these control systems. For all these branches which relate or study the control systems, the basic transform which is used in control systems is Laplace transform. So Laplace transform converts a time domain expression into a frequency domain expression. So that we'll be using in control systems. Control systems is also available for biomedical engineers with a course called as biological control systems. These Z transforms are equivalent to that of the Laplace transforms, but the signal which we use is a discrete signal here and not a continuous signal, whereas for Laplace transform the signal used is a continuous signal. The last fifth unit deals with correlation and the sampling theorem. Along with correlation, we also study something called as convolution, how these two are related and what kind of mathematical operations we do by using correlation and convolution we learn. Then we will also be studying the energy density spectrum as well as power density PDS spectrum. So we'll learn all those things and we'll study how to use these things to minimize noise. Then something called as a sampling theorem. Sampling theorem is very much useful for any thing which we want to transmit through a media. Communication requires sampling theorem at most. For example, ECG is a signal where a biomedical engineer should be of interest. Its frequency range can be from 0.5 Hertz to 150 Hertz if it is taken from a healthy person. The range can be taken will be from 0.5 Hertz to 150 Hertz for a healthy person. It can vary based on the conditions of the person. For this signal to be transmitted, how many samples should I take so that there won't be any loss at the receiver who is taking this signal? ECG is a biological signal. If there is a loss in the biological signal, then the doctor might diagnose it wrongly and can interpret it in a different way. So this might create a problem for a healthy person to be interpreted as an unhealthy person. So definitely sampling theorem is at most important when we transmit any signal. So these are the 5 units which we need to study under the subject signals and systems. So by studying this particular subject signals and systems, what a student will come out as a course outcome. The first one is characterize various signals. As we said, different signals we will be learning there, and then the systems, different systems and their classifications will be learning. Then their time and frequency domain analysis using different transforms. As we said, we will be learning different transforms. What will we use? A signal is used for a transform. Either it is a continuous time signal or a discrete time signal is used for transforms. This is the first course outcome which a student will get by studying the subject signals and system. The second course outcome is identify the conditions for transmission of signals through the system. So what conditions we should have for a distortionless transmission? So if signal to be transmitted through a system without distortion, what kind of conditions we should know? All those things can be identified. This is the outcome of a student after studying the subject signals and system. The third outcome is correlation, application of correlation. For what? I already said, power spectral density, PSD, and also ESD, energy spectral density. All those things are used for different applications. I said one application is noise removal. Otherwise, there are so many such applications which we can use the correlation and the PSD functions, power spectral density functions for different applications. That is going to be the third outcome for a student after studying the signals and systems as their subject. The last outcome which they will be getting is the sampling theorem. So for this is for baseband signals and bandpass signals. So for different types of signals, how do we do this sampling theorem? We already know what is the importance of sampling theorem. So this is a fourth outcome for the student for study after studying the subject signals and systems. So what kind of textbooks do we need to consider for learning this particular subject signals and system? The first subject textbook is Signals and Systems by Oppenheim, Wilsky and Nawab. This is the textbook. Similarly, the another textbook Signal Systems and Communications by B.P. Lati. So these are the two textbooks which are prescribed to for this particular subject signals and systems. There are also reference textbooks which are available is Simon Huygens. So this is Simon Huygens textbook, and the other textbook is by Phillips. So these are the two textbooks which can be used as reference textbooks. Yes, as a biomedical engineer, you are going to study now signal systems. What is that you are going to do in your 4-year career with this subject as the basic subject in second year, second semester. Thereby next, you will be studying one more subject called as biomedical signal processing in third year. And similarly, you will also be studying one more subject called as medical image processing. All these subjects require signals and systems as the prerequisite. With the knowledge of this subject, you will be learning much better the biomedical signal processing and medical image processing. For any kind of signal processing and for any kind of image processing, the basic subject a student should learn is signals and systems. Hope I have given you the clarity why you need to undergo the signals and systems subject. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.